welcome to the March 9th, 2021 edition of the Building Operators Association live presentation and meeting. We're doing this education series in lieu of our in-person meetings, which we certainly are looking forward to having again. Perhaps maybe in the early fall, we'll have the pleasure of seeing each other. We can always hope. Anyway, hopefully this summer we all get inoculated and life will return somewhat to normal.
Here.
Yeah. So hopefully you've all been visiting our website, which is www.boacalgary.com, and on there you'll find a wealth of information as well as recordings of this presentation, as well as the other ones, educational presentations we did in the fall and earlier this year. And there's some good ones in there. So so you can also find it on YouTube under Building Operator Association of Canada is our channel. And but you can just probably just as easy to go to the website and do it there. Either one works. Also, the magazine was emailed out to you last week, I guess, right, Les?
Yep, last week.
Yeah, and hopefully you got a copy of that. And there's some interesting articles in that as well. We're always looking for additional articles and comments, things, you know. It's okay to hold up your hand for if you have things that you want to see in the magazine, or for these presentations for that matter. And so we're always, you know, we welcome your guys' input on content or ideas or, you know, what have you. The presentation for next month is going to be on emergency genset maintenance, and I don't have a specific title made up yet, but working on that. And it'll be Miguel Parbeck. I don't even know how to pronounce his last name, but something like that, with Gentech Field Services. And he is also sponsors us, so he's certainly been very loyal to the Building Operators Association. So so we're looking forward to that presentation. And for May, I'm working on trying to get NMAX interested in talking about our electrical grid, and just waiting to hear back from them. And we'll see if that doesn't work out, then I'll pick an alternate along those lines, which should be another interesting topic, given some of the recent circumstances that happened down in Texas, and also some of the problems that one of the other electrical distributors has been having in southern Alberta just a few days ago. So so that'll be a good topic, and hopefully I'll be able to come up with something for that. This week we are doing, or this month, we're going to talk about when and how to maintain gasketed plate heat exchangers. That's a mouthful. And this presentation will provide a wealth of knowledge for best practices, with emphasis on the importance of utilizing optimal service intervals to prevent fouling and avoid unplanned heat exchanger breakdown maintenance spending. Certainly with the amount of higher performance buildings that we look after in Calgary and all over. We certainly need to pay a little bit more attention to heat exchangers and understand how they work and how they need to be maintained, because you certainly do not want to have one of those guys go down at the most inopportune time. So anyway, our presenter is going to be Kyle DeGostino. Sorry, Kyle, I never pronounced your last name correctly.
Close enough.
Kyle is a graduate of the Petroleum Engineering Technology program at the Southern Alberta Institute of Technology. Has had a little bit of experience in the field with fracking, I understand, and also now is more involved with heat exchangers. Kyle is the regional client manager for Southern Alberta for Heartland Solutions and Service. And of course, Kyle brings all of that knowledge he gained in school and in the field to both industrial process systems as well as buildings. And certainly it's good to have somebody, a go-to guy that's got knowledge on systems and piping layouts and that type of thing for both buildings and for process stuff in industry. So without further ado, Kyle's going to be sharing the screen now and starting his presentation.
Gotcha. Let me just share.
Welcome, Kyle.
You should see it now.
Yep, you're live and in color.
One sec though. We got a technical error on my end. Okay, I should be good. Yeah, thank you for that introduction. That was very well done. So like Mark said, I'm Kyle from Heartland Exchanger, and today I will be discussing when and how to maintain gasketed plate heat exchangers. It's funny you mentioned Mark. You don't want to have unplanned maintenance, and usually when that happens it happens when you need it the most. So if you're using a heat exchanger for heating, it's going to happen in the wintertime. If you're using a heat exchanger for cooling, it's going to happen right in the middle of the summer. Usually how it works. I'm sure you all have experience with that. But okay, so just to introduce Heartland Exchanger, they've been around since 1996. Back then they were known as Ramex exchangers, so I'm not sure if any of you have heard of Ramex, but that's who they used to be. In 1996, they became the sales rep for Alfa Laval and all of Alberta. And then in 2016, we went through an ownership and name change, and we were renamed Heartland Exchanger Solutions and Services. For the last almost 20 years, 15 years, we've slowly brought on more and more companies that complement the heat transfer side of the business, as well as servicing and optimizing heat exchangers. And then I'm sure some of you know about Alfa Laval, but that's sorry. Alfa Laval has been around for 160 years, invented the very first hand crank cream separator and the first gasketed plate heat exchanger for the milk industry and pasteurization. So just the agenda now. So first I'm going to start out with how gasketed plate heat exchangers work internally, their temperature and pressure limitations, the different flow regimes, the difference between single and multi-pass, the different plate types, and then the common problems that can occur with them: plugging and fouling, external leaks, internal leaks, plate deformation, and frame issues. And then, of course, how to monitor all those, how to prevent all those, and then how to solve those issues if they occur. finally followed by a Q&A. Before I get too deep into it, I just want to encourage everybody to ask questions on the fly. I can't see the chat box right now, but Mark Arton's going to read them out as they come up. And don't feel like you're interrupting the flow of the presentation. Just ask away, and I'll try to answer those questions as they, while we're on that topic. So next, so here's Alfa Laval's product range. Most of these heat exchangers you won't see in HVAC applications, so I'll just be discussing mainly the gasketed plate heat exchanger today. Just on another note though, the Alpha Nova in the right-hand corner, which also falls in the same family as brazed heat exchangers. You'll see that in HVAC applications as well. But more than anything else, you'll see gasketed plate heat exchangers. And there's a number of reasons why you'll see these more than Alpha Novas and brazed units. One of those reasons is, they are very efficient, which makes them compact with a small footprint. And just for reference, they're about 5 times more efficient than a shell and tube heat exchanger. And to further that, gasketed plate heat exchangers, for their footprint, they can open up and you can service them within that footprint. If you're dealing with a shell and tube, you need twice the amount of room to pull the tube bundle if you want to service it. So, it's 5 times smaller already, but then it's 10 times smaller when it comes to maintenance. So then, another reason why you'll commonly see them in HVAC applications is due to their design limitations and their temperature limitations, which fall, have a good range for most HVAC applications. The pressure rating, the highest pressure rating that you'll find is usually around that 31 bar, which equates to 3,100 kPa and 450 PSI. So we have 4 different frame types, one for 100 PSI, one for 150 PSI, one for 300 PSI, and then one that ranges between 400 PSI and 450 PSI, depending on the model. And then, of course, the temperature limitation is up to around that 170 degrees Celsius, but dependent on the type of gaskets. Another big reason why they're common in HVAC applications, you can open them. So you can open them to remove plates and service them, or you can open them so that you can add or remove plates to optimize between heat transfer and pressure drop. So it's a pretty handy thing to have, that you can, you can change your plate heat exchanger if your flow rate is ever changed, or if your pressure drop is ever changed. So good thing to keep in mind. Okay, so flow regime. So there's 3 types of flow regimes: counter-current flow, co-current flow, and diagonal flow. The most common that you will see is counter-current flow, and that's the first one that I'll explain. Now, here, let me just let the video catch up. So hot fluid comes into the top, flows down, and then comes out the bottom. The cold fluid enters the bottom, flows upward, and comes up the top. So the fluids are actually flowing in opposite directions. The fact that they're flowing in opposite directions gives you the best heat transfer. And with this type of flow regime, we can actually get what they call crossing temperatures. Does anybody there know what crossing temperatures is? Mark or Les, I'm going to test you here.
No idea what a crossing temperature is.
Hot side in to cold side out as the approaching temperatures make their change.
You're really, really close. How I'd explain the hot outlet is actually colder than the cold outlet, and vice versa. The cold outlet would be hotter than the cold outlet. So the temperatures actually cross on a graph. If you look at a graph, they cross. So the next one is called co-current flow. You will not see this commonly in HVAC applications, but I felt for the principle and knowing how heat exchangers work, it's probably important to explain it. So hot fluid comes into the bottom and flows up and then comes out the top. Cold fluid also comes into the bottom and then flows up the top. So they're flowing in the same direction. So you can't get crossing temperatures with this flow regime. And more commonly, you'll see this in like a processing industry where you may need to instantly cool a product to avoid crystallization, for example. You know, another one might be in the food processing industry where it's a consumable product and you need to cool it instantly for food safe. Downfall to this is that it may be more susceptible to thermal fatigue. Now I say maybe because it totally depends on the temperatures that you're dealing with. If you're dealing with like an 80 degree C temperature on the hot and a 20 and let's say like a 30 degree Celsius temperature, they're both entering the same point on that heat exchanger. So thermal fatigue, you know, may happen. But if the temperatures are closer, it may not. Next one is diagonal flow. I don't have a video for this one. This is sort of an obsolete unit. They don't make diagonal, also known as cross flow, anymore. And I'll show you why they used to do that. So here's the plate. Now, if you look really closely, you'll see in this area, you have kind of a small distribution area. So the fluid will come in through this port and then has to be distributed by this small area. And then it flows immediately down the plate and exits out this hole here. What they used to get with this old style plate was they get dead zones here. And that was due to a lack of turbulence. And with a lack of turbulence comes a lack of heat transfer. And also with a lack of turbulence comes a lack of what we would call a scrubbing effect, a cleaning effect. So that's when they came up with the diagonal flow. They'd say, okay, now a fluid's coming in here and it's going to come out the opposite left bottom corner. So it flows across the plate and covers more of that plate area. You know, it does increase the thermal efficiency and there's less area for fouling to occur, but it's not by any means perfect because you'll still get dead spots here and you'll still get dead spots here. Does that all make sense?
Yes.
Okay. So here's the new plate. Kind of hard to see, but this distribution area here, this curve, and due to egg port. So you have this egg-shaped opening. You know, now since we've improved this drastically, the fluid comes down and is spread out more evenly in this distribution area. For one, because it's a much larger area to spread out the fluids, but also because of the crisscross pattern in that curved flow. So that eliminates all the dead spots in the corners and forces the fluid to the outside and allows you to use the whole plate. Yeah. So as I said, you won't see diagonal flow too commonly anymore. If you do, it's in an older unit. But if you buy a new plate heat exchanger, you won't see diagonal flow anymore. And then
I've got a quick question from Sammy, if I could just interrupt for a sec. So Sammy is asking, which of these exchangers is commonly used at commercial facilities?
More like in any industry, counter current is more commonly used. You know, co-current will be used in very specific applications. You might see them as a one-off in applications that they shouldn't be in. Maybe because people purchased a heat exchanger from a you know, an outside source that wasn't designed for that application, and then they'll put it in, and or maybe due to piping changes. So if there's piping challenges, they might go, oh, you know what, it has to be co-current flow. You won't get crossing temperatures, but as long as you meet your design or your temperature program, then it will do the duty for that application. Answer the question?
Should be good.
Okay. So then keep in mind that all these flow regimes are, for simplicity, I've explained them as they're all single pass exchangers. So getting into the next slide, I'll be talking about multi-pass exchange. Now this diagram in this video that I'm going to show you is a 2-pass exchanger. So let me just play this. Now the hot fluid on the diagram and in this video, the fluid will come in the bottom, left port, and it flows into the exchanger, moves up, moves across a transition plate, and then comes down again in a second pass. And then it leaves out the back. So 2 major design differences that you'll notice about this right away is, 1, there's piping on both sides. Second is there's transition plates and partition plates within the internals of the plates. So the pro to this is it actually does increase thermal efficiency. So when you start doing multi-pass, you can get multiple crossing temperatures, what we would call. They would cross 4, 5, even more times than that, depending on how many plates and how many passes are in there. Now, the other pro is that, that reduces the footprint. So if you're doing a design and you have a really limited footprint, you might have to go with a multi-pass heat exchanger to get that temperature program within that footprint. The downfall to that is that there is piping on both sides. So when you go to service this heat exchanger, you're going to have to actually remove piping. Not only that, but if you go to add or remove plates, you're going to have to change your piping. So like I said, for this case, this is a 2-pass heat exchanger. Now, when you see ports on the front and back, both on the bottom, that's always going to be an even number of passes. So it's going to be 2 passes, 4 passes, 6 passes, or more. In other words, though, if you have piping on the bottom on the front and then it's leaving out the back top, that's going to be an odd number of passes. So likely it's going to be multi-pass exchanger, 3, 5, or 7. But it could even be 1 pass still, but it's just a poor design because there's no point in going to a single pass heat exchanger with piping on both sides and making maintenance more difficult. So next slide here. Les or Mark, can you tell me which one is a high theta plate? Which one of these plates is high theta?
Can't even guess, buddy.
I'm going to guess the left one.
Okay, maybe I shouldn't ask that.
It was a guess.
Yeah, so the one on the right is high theta. And the reason is if you can picture this, if you have a tube that goes straight down, the fluids are just going to flow straight down. But if you have a pattern that goes perpendicular to the flow, it's going to stir up the fluids and cause more turbulence. So if you look at the right plate, it's more of an obtuse angle. So it's forcing the fluids to the outside and stirring that up and causing more turbulence, which gives you more heat transfer. So there is trade-offs to both of these. The high theta plate is obviously going to have more heat transfer, but it's going to have more pressure drop. And then the low theta plate is going to have less heat transfer, but less pressure drop. So then I'm just going to show you the plate here again. I'm going to back up so you can see the whole thing. Can you see here that there's no gasket around the port? Can you see that okay?
Yeah, we can see it.
Yeah. Okay. So if a fluid was to come into this port, there's no gasket here, so it allows the fluid to flow down and then leave out this port. Okay. So the channel before this and after this is going to be the opposite fluid. So you don't want these fluids to mix, and you're going to want a gasket now on this side, and then you're going to want it to be open on this side. So what we do is we take the plate, we put the gaskets all on the same way, but we end up flipping it. So that's done two things. You actually have a gasket here blocking it to get into the next channel, and then you have it open to get into the next channel. The other thing that it does is now the chevron angle is pointing up when before it was pointing down. So when you change it, every second plate, you get these different plate patterns. And that's my diagram here. So the first diagram on the left, you see two high theta plates overlapping each other. This plate pattern will give you the most heat transfer, the most turbulence, and the most pressure drop. Now the one in the middle is a mixed theta channel. So it has a high theta overlapping a low theta plate. Now that will give you medium heat transfer, medium turbulence, and medium pressure drop. And then the one on the right is two low thetas overlapping each other. And that will give you the lowest amount of heat transfer, lowest turbulence, and lowest pressure drop. And then, of course, all heat exchanger design programs will use these different plate patterns to optimize between pressure drop and heat transfer.
I have a quick question for you before you move on. So would the application be different for, say, chilled water or heating because of that characteristic, or it doesn't matter?
You're talking about if you were designing a heat exchanger and it's chilled water.
Well, what there is there's a big difference in your delta T, heating versus chill water. You're working at different temperatures, right? Or different range, I guess.
Yeah, I see what you're saying. Yeah. So if you're dealing with, colder temperatures like that, your hot fluid isn't that much colder than your cold fluid. That's what you're saying, right? That's what you're getting at.
Yeah. So the application between heating or cooling, the biggest difference in the application is, other than the amount of glycol or whatever, is the range and temperatures that the system is, the heat exchanger is seeing.
Yeah.
Like chill water doesn't have as much of a change in temperature as heating does.
Yeah. No. When you have two fluids that are closer in temperature, it's tighter to get that temperature approach, I guess, because you don't have as much. You got to do a lot of thermal duty to bring it down that extra few degrees. So you're absolutely right. They need to be really efficient heat exchangers. They need to be counter current. You might need high theta plates, but it does also depend on how much pressure drop you have available. When you design a heat exchanger, you want to use all the available pressure drop that you have. So I always ask clients, what's your available pressure drop? And they'll say 10. I'll say, okay, what's your maximum available pressure drop? And they'll say 12. So you want to get that maximum to utilize that to get more heat transfer. That makes sense?
Yeah.
Okay, so common problems with gasket plate heat exchangers. Now, I'll be talking about plugging or fouling, external leaks, and all that fun stuff. And then I'm going to be talking about how to monitor, prevent, and solve all those issues. Just next slide. Okay, so monitoring, plugging, and fouling. Can you guys tell me the difference between plugging and fouling?
Not sure. They're both bad. You gonna try that one, Les?
He's muted.
He's muted. He's given up on us.
Okay, I'll just.
Well, I would imagine when you plug one up, it means that you're actually the medium that you're putting through there is actually crystallized or in some way is preventing flow, and fouling is where the plates get coated. But that's just my guess.
Actually, you're bang on with the fouling. Fouling is when the surface of the plates get coated. I'll show you these pictures here. So plugging, you know how you have a specific size of channel. You'll have a specific pressing depth ranging between 2 millimeters and 4.5 millimeters, let's say. If you have debris that goes into your exchanger that's bigger than your channel, it's going to get caught in the port. So that's what we call plugging. Right?
Okay.
And then fouling is when, you know, it gets through the channels, but fouling comes out of precipitation and out of the fluid. It gets deposited over the heat transfer area of the plate, or the distribution area for that matter. But it's deposited on the surface of the plate.
See, I would have guessed that.
Well, you were
I've
muted.
got a zinger here for you, and you don't really have to answer it, but earlier on today, the ASHRAE was talking about air-to-air heat exchangers, you know, which are used more or less on air conditioning, mostly, be condenser coil. But what they were saying is the more that they get externally fouled, you know, with debris and fuzz and stuff, the more efficient they are. The more
really?
heat transfer that they get. And you would think that that would be just the opposite, but that's not the way it works.
I wish I knew more about those so I could use my little science brain to figure that out.
But isn't that interesting? So I guess my question is, do you run into anything like that with two different kinds of fluids? I guess that's a hard one to answer.
Unfortunately not. The plates are so thin, you know, they range from 0.4 millimeters thick to, you know, you can get older units that are 1 millimeter thick, but those are big clunker gasketed plate heat exchangers compared to what we have today. And it's so, being that the plate is so thin, you know, it gives you more heat transfer, right? The thinner the plate, the more heat transfer you'll get. But then again, you got to be careful with that, because if you get too thin, these plates can badly deform under pressure, or even under installation. So, and then dependent on the type of gaskets too, if you have a higher grade gasket like HNBR, it's a more hard gasket. So you got to be really careful with the plate thickness there. To answer your question, you get a coating on this plate and it ruins your heat transfer. And, you know, the funny thing is a lot of people will just run with foul heat exchangers. But if you do the math and you look at the thermal duty that it's costing you over, say, 10 years, you're better off servicing that heat exchanger, pulling it right apart, cleaning the plates, replacing all the gaskets, and your payout is in, you know, could be 2 to 3 years, could be less, depending on the thermal duty. So yeah, to answer your question, no, it gets less efficient as it gets going. Good question.
How do you, excuse me, Kyle, how do you determine whether it is plugged or fouled?
Okay.
Gradual increase?
Yeah, that's a good question. So I have a couple things that you should keep an eye on when it comes to plugging and fouling. Now, I always recommend keeping like a daily record sheet with pressure drop and all your temperatures. When you're going around doing your daily checks, because I know everybody does it with their pumps and all the other equipment, check the heat exchanger. You know, make sure that the temperature gauges are reading accurate results and the pressure gauges are reading accurate results, but record that daily. For example, if you're recording every day and all of a sudden the next day you see this big pressure spike, it could mean that you took on something on the open loop side from the cooling tower. You know, you brought a plastic bag, for example. I've seen Tim Hortons cups, right? They get sucked into that port and they sit there and they just increase that pressure. And then the other thing that it'll tell you is over a long period of time, you'll see that heat transfer or pressure drop slowly increase, which could be a couple things. You've slowly taken on more and more debris, like shown in that picture. You've taken on wood, and in turn, you have a slow increase in pressure drop. Now, as fluids work through the channels and you get fouling, like the picture shown on the right, that's going to be a slow decrease in heat transfer. And when that channel does become more and more plugged, you'll see an increase in pressure drop as well. But you'll see a decrease in heat transfer more drastically than you will pressure drop when it comes to fouling. Another way that you can keep an eye on, at least fouling, to say the least, is with a thermal camera. So I don't think a lot of people have thought of using this on a plate heat exchanger, but a lot of buildings have them. So you kind of got to know how to read them. This one is fairly obvious in this photo. You can see the dark spots here. That's an evident loss in heat transfer. Like I said, most buildings have them. If you want to send me some pictures with your thermal camera, I'd be happy to assess them for you. If you don't have a thermal camera, we have one, and we can come to site and actually, do an audit on your heat exchangers. So keep in mind that all these ways that I'm discussing is knowing if your plate heat exchanger is fouled or plugged without opening them. Because if they're fouled or plugged, you don't want to just open them up. It's like opening a can of worms, and then you might need new gaskets. So it's important to keep them closed and try these ways first before you open them. So last one I'll mention is a performance audit or a performance check. We need 4 temperatures and 1 flow rate to do this check, and we check it with our design temperature or our design programs. What happens is we take the thermal duty of the exchanger today, and we compare that to the thermal duty when the heat exchanger was brand new. We divide those 2 numbers, and then that gives you a percentage of the efficiency of your heat exchanger. So whether it's at 60%, 70%. And then if you do this a couple times, see the black dots on the graph? The black dots actually represent when the performance audit was taking place. So if you do this at least 2 times, you can draw a trend in a linear fashion and figure out an exact service interval. And this is really important. You're not waiting too long in between cleanings, and that you're not cleaning too often. Cleaning too often results in unnecessary maintenance spending. And waiting too long in between cleans, for example, if your gasket life, still has 7 years left, and you want to CIP your heat exchanger, then if you don't wait too long, you can CIP it. If you wait too long, you can't CIP it. You got to open it up. So it's important to hit those service intervals, as close to the right time as possible. And that time that we recommend is right near that red and yellow line, where the red and yellow zone meet on that line. That's when you want to service it. You don't want to wait till it gets into the red. Now, the challenge in HVAC applications is that most don't have flow meters. So they have no idea what their flow rates are. If you have an ultrasonic flow meter, you can check this externally while the heat exchanger is running. And you don't need to shut it down. There's no downtime. You just take a flow rate, check your temperatures on the gauges, or check it with a heat gun. And if you don't have an ultrasonic flow meter, we have one that we can help you with. Okay, so fouling prevention. First thing that I'm going to mention about fouling prevention is having sufficient flow rates. If you don't have sufficient flow rates, you won't have sufficient velocities and you won't have sufficient shear stress. Shear stress and velocity is a relationship to flow rates, and that's how it's calculated. So there's an actual value that we have set. We say 50 pascals of shear stress. If you don't have 50 pascals of shear stress, you'll notice on the graph here, it's in like a logarithmic form. So if you have less, you see how it increases exponentially. Your fouling resistant growth rate increases exponentially. So anything above this, you may see an improvement on fouling resistance growth rate, but it's not huge and it's negligible. So aim for that 50 pascals is what we do. Keep it on or above and you should be good. Okay, so the next one I'll mention is proper water treatment. That is really important. And then to treat or to prevent plugging specifically, you can use upstream filters or port filters. Do you guys know, have you guys ever seen a port filter in action?
During construction.
Okay, yeah, because the upstream port filters in the HVAC industry are pretty common. You won't see the actual port filter too much, but anything on that open loop side of the cooling tower, it's not a bad idea. What happens is, here, let me grab my heat exchanger. All 4 ports are on the front. So what we do is we put an inspection port on the back and we slide that port filter from the backside. And so if you need to shut down, you shut your exchanger down, you drain it down, and then you pull that port filter out without having to remove piping. So you can utilize that too if you're noticing lots of plugging. And the benefit of this port filter over upstream filters is it gives more service area, especially in a large plate.
Uh-oh, buffering.
Is that what it says?
No, but that's what it is.
Oh, okay.
He moved his hands too quick. It happens. It's a Zoom thing. Yeah. Well, hopefully he comes back here shortly.
More service.
Oh, you're back. We lost you there a little bit there. So,
Yeah, I'm good.
so you're good now.
No, a warning came up. Internet was unstable, so hopefully it doesn't do that again. Okay, so other ways to prevent plugging and fouling are through online cleaning systems. So there's a few that are helpful. The backflush valve. That's a valve. What it does is it reverses the flow of the heat exchanger. Okay, so with a plate, and it's hooked up to like a timer or a computer system that allows it just to switch directions of flow. This is actually really common in the US in the HVAC industry, but you don't see it in Canada too much. Takes some time to catch up in technology, I guess. But yeah, so the backflush valve and just rotating that the flow direction, it gives the fouling less time to sit on the plate and accumulate, and just reverses that flow. Next one I'll mention is the descaling device. So this is good for preventing and eliminating existing carbonate scaling. And then, of course, here's the online ultrasonic cleaning for really heavily fouled applications. And then anti-fouling coatings as well. Okay, so whether or not you use all those forms of preventing plugging or fouling or not, a time will come when you need to service your heat exchanger. A good way to treat plugging and or fouling is with a CIP. So A CIP, if you have the right chemicals, it can remove the fouling on the plates. And if you reverse circulate it, you can remove the plugging in that port. So there is, 3 important parameters to get a successful CIP though. You want to have proper flow, you want to have good effective chemicals, and then an on-site lab is also important so you know when that chemical has been spent.
Kyle, CIP stands for clean in place, right?
Yeah, clean in place, or also known as chemical cleaning in place. Yeah, correct. So another couple things about CIP. Before you invest your money into this, there's 2 questions that you should ask yourself. What is the efficiency of the heat exchanger? Okay, if it is below that 60% efficiency, I'd be cautious there. Because if the channels become too plugged, a CIP, it's like hitting a wall. The chemicals, it won't be able to penetrate. So you want to be able to get flow through that exchanger to get a good CIP to dissolve the chemical, the fouling that it comes in contact with. The other thing that you want to consider is, what are the age of the gaskets? If it's a 20-year-old heat exchanger, not sure that it would be the best thing to invest your money in a CIP. At that point, you could, if you do end up doing that, you could circulate chemicals through, and then the year after it's leaking. So the year after, you got to pull it apart, replace all the gaskets. You'll have to CIP again. So it's best, to know the age of your gaskets and, kind of predict if they're going to fail or not soon, and then just do the full service. Okay, so next slide here. Okay, so external leaks. Now, when you have an external leak, it is always a gasket issue. And here's why. We have these windows out the side of the gaskets here. And you have this area where 2 gaskets kind of almost meet. And you have the gasket around the port. And then you have the gasket separating the channel. Let's go back to the plate here. So you have these 2 gaskets. If a fluid was to penetrate this gasket, there's these windows here that allow it to leak externally. Same with this. If if a fluid was to penetrate this gasket, it would allow it to leak externally. So every time there's an external leak, it's always a gasket issue. Now, one thing I'll mention is, when you see an external leak, the tendency for people and workers is to take a wrench to the exchanger and tighten it up, because you're squeezing the gaskets and it might seal up the leak. I'll tell you, that is the absolute wrong thing to do. You do not want to do that. Your A dimension is calculated based on the number of plates and gaskets, along with the thickness of the gasket and the thickness of the plate. So that's an exact measurement. You have a little that you can play with, but the last thing you want to do is just take a wrench and tighten it up. You want to know your A dimension, you want to know your tolerance. And then if it's a really old exchanger that you're not too familiar with the history of it, maybe there's a different number of plates in there. So you want to verify a plate count, you want to check that thickness of plates before just listening to the A dimension that's on the nameplate. So please don't just go and tighten it. Make sure you get some expert advice on what to do in that situation. And then another thing too, if you have one gasket that's leaking, it's a good indicator that the rest of them are about to go. So I don't know how many buildings I've seen when they go, okay, that gasket's leaking on a 10-year-old heat exchanger. So they open it up and they replace just the one gasket. They close it up, maybe a month later, it's leaking again. You got to open it again, change that gasket. So you're just chasing leaks. So when a gasket fails, replace all of them. And then some other things that you can do besides the obvious of just watching for external leaks. Keep an eye on the ground for dry solids. It's quite possible that the heat exchanger could have been leaking at one point, but then maybe the weather warmed up and the gaskets expanded and sealed the leak, but could have left evidence of dry solids on the ground around the exchanger. So could be a good indicator of a leak. As well as dislocation of gaskets, crushed gaskets, and misalignment of plates. If you're seeing this, even if there isn't a leak now, it could be a good indicator that a leak could happen soon. So, check the heat exchanger, make sure you have that perfect honeycomb pattern and that the gaskets aren't out of place. And as long as everything looks good, then you've done your due diligence. Okay, so this is how gaskets behave over time. Now, in transportation, you'll see you have a line that goes across and then it kind of goes up. And the reason for that is when you put it into service, it tends to warm the gaskets up and it actually increases that sealing force. So then the gasket slowly drops over time in a linear fashion. Every time you take it out of service, that compression or that sealing force decreases. The interesting part is when it gets to that dotted line there. When it starts getting close, if you take it out of service and you see a leak while the heat exchanger is still flooded, that's what we call a cold leak. You put it back into service and it seals itself up again. But, that's just a good indicator that the gaskets are getting close to the end of their life. And you should start looking into a replacement set of gaskets. So external leak prevention. So like I said before, avoid opening it at all costs. You could have a plugged or fouled heat exchanger. And the last thing you want to do is just open the heat exchanger up. Unless you absolutely have to. If you've done your due diligence and you've checked everything, and you need to open it, then open it and change all the gaskets at once. But don't just open it for no reason. And then another good leak prevention is proper gaskets. So your choice will depend on a combination of temperature and pressure, as well as what type of fluid are you dealing with. If there's any chemical attack on the gaskets, you might want to go to like a higher grade, from NBR to NBRP to EPDM to HNBR or even Viton. But chemical attack probably isn't too common in HVAC, but you might see it, so you might have to go to a higher quality gasket. Quality is also really important. Now, when I talk about quality, I talk about, our preference is always going OEM for gaskets. You can go to aftermarket gaskets. There is usually a trade-off in the quality, but know where you're getting your gaskets from. Hopefully you're not getting them from a cheap overseas company. It doesn't pay to get those gaskets, even though, the initial dollar amount might look worth it. If you're getting, even half the run times, then it's probably not worth it to go with a lower quality gasket. So always know your source, know where you're getting your gaskets, and take into account your run times. And then the grade of gasket is also important too. So there's 100 different grades of EPDM, 150 different grades of NDR. So as well as quality, make sure you have a good grade of gasket. External leak solutions. So one good solution is always having a spare set of gaskets on hand. At the very least, if you don't have a spare set of gaskets on hand, at least have the information about your exchangers on hand. You can look from the outside of the heat exchanger and tell what kind of gasket you have. So you want to have the drawings or paperwork on hand, or at least know the gasket material, know if they're clip-on or glue-on, and then know your delivery times. And then another external leak solution would be a recondition, which I'll go into more detail about later. Now, monitoring external or internal leaks. Actually, let me back up a bit here. So internal leaks result in cross-contamination every time. They can be caused from corrosion, erosion, fatigue, temperature surges, thermal shock, and manufacturing defects. So monitoring them is kind of tricky. If you have a water exchanger, you're not going to be able to test your fluids to see if there's intermixing. But if there's glycol in water, you can test your glycol and see if there's water in it. If your glycol percentage is decreasing throughout the system, then you could be able to test and could be a good indicator that you have cross-contamination. A tool that Alfa Laval has coming soon is an integrity tester. I can't say a whole lot about it, but I can tell you this: it will be able to detect internal leaks even before they happen. So it will be able to estimate when internal leaks are going to start happening. And you can do this all without opening your heat exchanger. It's a really interesting piece of equipment we have coming. And then internal leak prevention. So, one good thing you should always keep in mind that when you're starting and shutting down your heat exchanger, open and close the valve slowly. Your instruction manual will tell you this, so follow the steps on the instruction manual. But one main thing is opening and closing those valves slowly, so you don't get that pulsing and shocking and damaging the plates. And then proper flow rates and velocity. So remember how I talked earlier about your shear stress being 50 Pascal. You'd think that the higher shear stress you have, the more turbulence, the better scrubbing and cleaning effect you'll have. But I'll tell you, if your shear stress and your velocity is too high, you can get erosion of the plates and it can eat through the plates. So you want to have a good balance there. And then again, proper water treatment. If your chlorides are too high, they can deposit onto the plate and eat their way through. If you have high iron content in the water, then it can rust through the plates. And then, of course, if you have high chloride content, like in a pool or a hot tub application, probably have to look at a higher grade of plate material. So maybe SMO 254 or titanium. And then when your heat exchanger is not in use, make sure it's drained so that the fluids aren't just sitting in there and chlorides have have more time to latch on and eat through the plate. And then when you remove the plates, make sure that the plates are all cleaned and at the very least wiped down, especially when storing long term. Okay, so getting into plate deformation. The diagram above here is how gaskets should look. They're flat and even with the plate. How they should not look is the diagram below, how that gasket kind of curves up. What it's showing is the deformed gasket groove specifically. So the plate kind of protrudes up into the next channel. So you actually get less sealing force, which makes it more susceptible to leaks sooner. So that's plate deformation in a nutshell. What causes this is over tightening. So when I talked about leaks and people, taking a wrench to their exchanger and over tightening, you're actually crushing the plates, and that's what causes this is plate is over tightening. As well as there's another different type of plate deformation, which would be caused in the distribution area. This is normally caused from pressure surges. And it's because of how the distribution area is made. It's not as strong as the heat transfer area, this herringbone or chevron angle. It's corrugated, so it gives the plate more strength. So when there's pressure surges, it's commonly going to occur in this area, which could be a domino effect and affect this gasket groove here, and you might get leaks sooner. But yeah, that's the two different types of plate deformation. So monitoring this is kind of tricky to monitor this. It's tricky to see from the outside, but checking your A dimension is, could be an indicator that you have plate deformation. If it's smaller than it should be, then your plates are likely warped. So other than that, you have to have your plates removed to kind of see the plate deformation. So it should be a flat groove in here. If it's protruding up into that channel, that's plate deformation. And then we have a tool that actually measures it specifically. So we'll be able to tell you with this tool if it's in the yellow zone or if it's in the red zone. And if it's in the red zone, we'll say, look, they're past the deformation limit. You need a brand new plate pack. Or maybe there's only 10 out of 100 plates that you need and you have to replace those 10. But we'll be able to tell you, pretty accurately if you should get a seal or not with this tool. Okay, so frame issues. So monitoring frame issues. Really all you can do here is a visual inspection. And then prevention is, just take good care of your heat exchanger. Avoid toolboxes being rammed into it and chipping the paint on the outside. When you open the heat exchanger, open it carefully. Keep all components dry and, clean and dry. And then keep the tightening bolts greased and protected with the thread protectors to avoid thread damage. And then end gasket leaks. If you have a gasket leak on the end plate and it's coming into contact with that carbon steel frame, it could corrode fairly quickly. You want to deal with that. You want to deal with that sooner than later. And then problem solving it. If there's some minor parts that need to be replaced, like a tightening bolt or a roller bearing, we can order those parts. More than often, we need to know in advance because sometimes they can be a long lead time, dependent on the model of the heat exchanger, especially if it's an obsolete or older model. If it's a major component that needs to be changed, like a pressure plate or frame plate, you're better off just buying a new heat exchanger in that case. Because when you change the pressure containing components, you have to go through ABSA, third-party inspectors, get it recertified, and so instead of just going that route, you're usually better off getting a new heat exchanger. Of course, our field service, every time they do a plate pack swap, they check your frame for you. So they inspect the port liners to make sure they're not warped. They clean and inspect the whole frame to make sure it's in tip-top condition. And then the reconditioning as well. And if you send in the whole exchanger, then we'll clean and inspect the frame at that time. Okay, so I kind of left this till last because all those problems that I discussed previously, plugging, fouling, internal leaks, external leaks, plate deformation, reconditioning, we deal with all those problems in our reconditioning process. So, first of all, we start out considering if you send in just the plate pack alone, we'll start with a thorough inspection. But if you send in the whole exchanger, the first step is to open up that plate, the exchanger, remove the plates, do a full frame inspection and clean it. And then we'd start with step one here. So at step one, you're starting out with a thorough pre-inspection. At this point, you're looking for, how bad is the fouling? If the fouling is bad enough, we might have to do a pre-wash before we put them in the chemical tanks. You're also looking for plate deformation, obvious pinholes or cracks, anything that you can see visually. If it's cracked, then there's no point putting that plate through the reconditioning process. Next step would be the gasket removal. This is for glued gaskets specifically. So we take the plates and we dip them into the liquid nitrogen tank, and the gaskets instantly shrink and fall off. Next step is the chemical cleaning. So we have an acid bath, a neutralization tank, and then a caustic soda bath. So we'll go back and forth between these tanks and pressure wash in between until all the fouling has been removed and the plates are brought back to brand new condition. Then secondary inspection, you'd have to do this if there's a heavy amount of fouling. And then again, you're looking for pinholes or cracks, obvious pinholes or cracks before it goes to the dye pen stage. And then the dye pen stage, that's when we spray the plates with dye, and then we slide them into a room with black lights, flip the plate over, and if you see any bleed through, then there's a pinhole or a crack that you couldn't detect with human eye. And then they re-gasketing. So we use a 2-part oven cured epoxy that we squeeze onto the gasket groove. Then we apply the gasket. We put compression on it, and then bake it in an oven to oven cure the gaskets on. And then we put it back into the heat exchanger and pressure test and send it off to you again. And that is the end of my presentation. So any questions you guys have, I'd be happy to answer them.
So we do have one question from Sammy. He's asking, fouling and scaling tend to be a huge maintenance cost on heat exchangers. How often would you suggest water treatment is done to mitigate these problems?
That is the thing. It all depends on your water quality. It all depends on the application. Temperature can be a large effect there. If it's above 75 degrees C, then carbonate scaling is going to bake onto the plate sooner than they would on like a cooling process. So it all depends. You do want to use tools to kind of estimate your service interval, like a thermal camera or a performance audit. And it just really varies. It's different inside every building, and it's different inside every application and every heat exchanger. So that hopefully that helps.
So the next question is, how does the cost of, and this is from Steve, how does the cost of PHE compared to just buying new plates and gaskets?
Oh, like a brand new heat exchanger to plates and gaskets. Okay, that's a good question. Full replacement plate pack, dependent on the size, I'll add, is usually about 80 to 90% the cost of a brand new exchanger. So if you have a large heat exchanger that's say $200,000, a brand new plate pack would be $160,000. So there's a $40,000 cost saving there. Now, it's also, if you're buying a brand new heat exchanger, you could piping changes. So you want to be careful with that you're getting an exact duplicate. And then the reconditioning process, I'll add this too. The reconditioning process is about 50 to 80% of the brand new plate pack. But if you get a really small heat exchanger, something that's this big, you very well might likely be better off to buy a brand new heat exchanger than do a reconditioning.
Well, that looks like all of the questions we have. We're sort of running on a little bit on time here, so so that was a good talk. I would imagine I should mention also that you volunteer your services to as part of the executive on the Building Operator Association. I should have added that to your credentials, but anyway, they'll find your contact information on our website and also in our magazine. So you're a regular contributor with us, and so I thank you very much for the wealth of knowledge on heat exchangers, and hopefully, I guess the message is, don't wait till it's too late.
That's right, and no service intervals, and that's the tricky part. So, yeah, I do attend every meeting as well. So if any of you guys are presenting, I'll be watching you in the background. So, I try to be fairly involved with the Building Operators Association, and I'm happy to be a part of this organization. And I do appreciate you guys letting me present here today. And if anybody wants to have a talk outside of here, you know where to reach me.
Absolutely. Well, that's awesome. Any final comments, Les?
I can't think of anything. Thanks for that presentation, Kyle. The one comment that I had is if because I have a building that's much older and I don't have the cross flow plates, do I have to have it re-engineered if I wanted to go to the newer type plates?
Oh, do you have crossflow plates in your building?
Yeah. No,
Oh,
I have the older ones.
Oh, the crossflow plates are the old one, the diagonal flow.
Yeah.
Maybe I explain. Okay, so
But my question is, if I wanted to make a change, do I have to have a mechanical engineer to respect them? Or can you guys do it?
it all depends on the make and model there.
Yeah.
We do represent Alfa Laval, exclusively. But we do work with other OEM manufacturers. So we have a wide range of companies that we can go to. It all does depend on the make and model though, and the age. It might be an obsolete unit, so you might not be able to get that unit anymore. But then what we could do is we could look at it, a newer Alfa Laval model where the ports are close, and it could be minor piping changes. But yeah, if you want to look at upgrading them, then it's all kind of, we'd have to look at that individually.
Okay, good. Well, thanks a lot for your time and your knowledge there, Kyle.
Yeah, no problem. Anytime. Thank you.
All right.
Okay.
So everyone, don't forget next month we're going to be talking emergency generators, and with Miguel with Gentech, and so looking forward to that on April 13th. Les and I are also working on another mini series that hasn't rolled out yet on just on some HVAC little mini series on HVAC, but we'll keep you posted on how we're progressing with that. In the meantime, look forward to our magazine that comes out, and you're always welcome to have a look at our website and see what's going on. And so Les is doing a good job now of keeping that updated. So anyway, looking forward to our next presentation. Bye for now, and hopefully you'll be able to get your shot soon. The good old COVID-19 thing needs to go away as soon as possible. Anyway, have a good one, guys. Keep your stick on the ice.
Thank you guys. Appreciate it.
All right.
Very much.
Well,
That was good, Mark.
I gotta cancel the recording here. There it is.
Now it'll start backing it up for you.
You have to kind of keep it active.
Yeah, I kind of got to keep it going while it's downloading and backing up.
Well,
you
I don't know how this is going to work because
it's just going to show up on your.
with my device, I don't have email, so
Well,
it's
okay.
saying that it's gonna. I'll get an email notification when the recording is ready. Well, I won't, because see, this is not a computer, Les. It's an iPad.
I know, but if you have it,
So it's hopefully recorded in the cloud somewhere, and
yeah,
we'll just have to figure out how we can retrieve it.
Yeah.
I have no idea.
it usually downloads to my documents. And it'll just show up as a Zoom. So
Yeah, but this isn't a computer, so I don't have my documents.
You don't have documents. Okay, well, it'll probably tell you where it's located. If not, well, hopefully we'll have
But I
Kyle.
have no idea why that
Didn't do it. Yeah, I don't either.
So
'Cause
it looks like